by adding the same amount to the salary every year, and the other one was changing by multiplicative increase, and that was the teacher salary. Which one is exponential growth? Additive or multiplicative? Yeah, multiplying. Okay, we are... And so, what is the growth factor? The growth factor is the amount that we multiply by what? By the output or the input? By the output to get the next output. The next output. Or the output for 1 year later in this case. So 1 unit here is 1 year. And so this times 104 gives us the next year's salary by multiplying the previous year's salary. So this is output. And notice that our multiplier is on one output to get the next output. So how did they get year 8 salary from year 7 salary? So given year 7 salary, how do you get the salary in year 8? Multiply by 1.04. So it's very convenient with these exponential functions because within a particular type of growth, that growth factor doesn't change. It always is that 1.04 to get the next unit of output, no matter what year you start at or what input you start at. So for an increase of 1 year, the new salary is always 1.04 times as large as the salary of the previous year. So this is review. This is review. Okay, what about how would we get, given the salary at year 0, how would we get the salary at year 3? Okay, so there's actually kind of 2 ways to get this. How would we get the salary in year 3 from the salary in year 0? Any ideas?
Take the year 0 salary and multiply it by 1.04 to the third.
Okay, why would you do that?
It's 3 years later.
Okay.
So you need to multiply it by the 1.04 3 times.
Yeah, so to get, we just talked about, exactly. We just talked about to get the salary the next year, multiply by 1.04, and then the next year after that, 1.04. And then to get it in year 3, multiply by 1.04. So what is this? The cumulative effect of multiplying by 1.04 3 times. Yeah, it's the same as multiplying by 1.04 to the third. So let's find that value. So put it in a calculator. Take 1.04 to the third. Anybody got it? Shout it out as soon as you get it. 1.125. Okay, so because this is a different multiplier, what's the effect of this multiplier? The effect of this multiplier is to give you the salary. What salary? 3 years later, not the next year, but 3 years later. So the 1.04 gives you the salary the next year. The 1.125 gives you the salary 3 years later. Okay? What would be another way to get that 1.125? If we knew the salary was 41,000 and then 3 years later it was 46,119.42? What's another way to get that 1.125? Difference. So that one minus that one.
Yeah.
Is that right? Agree with that? I take this and I do minus this. Times it by a third. Any other suggestions? How do you get the number that you would multiply 41,000 by to get 46,119.42? Yeah, it'd be division, right? It'd be division. So find that. So do that division. 46,119.4 divided by 41,000. And you should find that you get same thing, 1.125. So if it's the multiplier, then it should be the quotient of 46,119 divided by 41,000. But it also comes from multiplying by 1.04 3 times. So those numbers are the same. So let's move on here. Okay, does it make sense? So this is our number one. Let's. So this is what we talked about. By how many factors of 1.04 is the original salary multiplied? 3 of them, right? 1.04 cubed. So this is a different kind of growth factor. So this is a growth factor for an increase of 3 years. Okay, we said that was 1.125. So we can call this the 3-unit growth factor. So that 3-unit, is that referring to the input or the output? The 3 units, is that referring to the input or the output? What do you think? The 3 units. It's referring to the output. So where do we see 3 units here in this output from 41,000 to 46? Where do we see 3? We don't really, right? Where do we see the 3? The input, right? From 0 to 3. So we have different growth factors. This one's a 3-unit growth factor, and they're named based on how far you advance in the input. Okay? Okay, so the name of the growth factor refers to how far you're going to advance in the input. But that growth factor, 1.125, it's a multiplier on what? Input or output? Oof. Tired? What's going on? What is this a multiplier on, the 1.125? Output or input? Output, right? So it's still a multiplier on output. The name of it refers to how far you advance in the input when you make that multiplication. Okay, what's the percent change then? So what percent change do we see every 3 years? 12.5% change, increase. Just rename that. So this 1.125 is the 3-unit or the 3-year growth factor. Okay, so how many times, based on all this stuff, how many times as large as 41,000 is 46,119? That's our growth factor, 1.125. Okay, so here we go. We're in salary in year 6. How do we get the salary in year 9? By how many factors of 1.04 does the salary increase from year 6 to year 9? It's the same thing, right? If every year it increases by a factor of 1.04, then in any 3-year period, it's going to increase by this factor of 1.04 to the 3rd. So just like the growth factor stays the same, the 3-unit growth factor will stay the same because it will always be 3 1.04s multiplied together, no matter what year you start in. So for an increase of 3 years, the salary is multiplied by 3 factors of 1.04, no matter what 3-year period interval is selected. Doesn't matter. So let me just give you some practice here. So I want you to find the 8-year growth factor. Find the 8-year percent change. Write the function for the salary after X years. Call it f of x, and then write the function g of n. N is the number of 8-year periods. And then find the salary in year 15 using 8-year growth factor. So, practice. 5 questions. Okay, feel free to compare your work, ask each other questions, or catch me if you've got a question. This is good practice. You should be able to do this. From what we did today? Yeah, we should get the data class. It's asking to, it's just like number 3, but instead of the input being the number of years, the input's the number of 8-year periods. Does that make sense? So n means how many 8-year periods. compare your work with each other? That changing that question? Okay, how would you find the 8-year growth factor? What would that be? He wants 1.04 to the 8th. Agree with that? Yeah, because if we want to advance 8 years, it would be the same as doing what? Yeah, multiplying by the 1.04 8 times, and we get a value for that. Is it 1 point? So let's go to 1.369. So let's do 1.369. Okay. So then what's the 8-year percent change? The percent change. How much does the percent change? Or how much does the salary change? Does it change 136%?
36.8.
So remember, rewrite, practice, just get in the habit of always rewriting the growth factor as either 1 plus or 1 minus. In this case, it would be 1 plus 0.369. If it's 1 minus, you got decay, right? So 1 is always what you keep from before, and then plus either the percent increase or minus whatever the decrease is. So we got 36.9% increase every 8 years. Every 8 years. Okay, function for the salary. Starting amount? 41,000. So if we want to advance X years from 41,000, we're going to multiply by 1.04 X times. So when you see that function, that's what you should see. You should see, I'm going to start with 41,000. I'm going to multiply by 1.04 that many times to get the salary after that many years. Repeated multiplication. That's your image of these functions. Repeated multiplication. Okay, the next one's a little trickier. We haven't done one like this yet. So number 4, we got GN. So does the initial is the initial salary different? No, it's still the same. Okay. So the question is, how do we handle this? So if our exponent is n, and that's the number of 8-year periods, here's how you do it. Whatever the exponent, the period of time is for the exponent, will be the corresponding factor that you want inside there. So what do we want in the parentheses? If n is the number of 8-year periods, what do we want in the parentheses? Yeah, we want the 8-year growth factor. 1.369. So those have to be a match. Here's the key to knowing how to do this. Your exponent, the time shift of the exponent has to be the same as the time shift of the growth factor. So if this is the 8-year growth factor, this is 8-year time increments. If it's the 8-year growth factor, it's the 8-year time increment. So we could, Try me again. No, that doesn't work. No, because look at what it is. Where did the 1.369 come from? It came from 1.04 to the 8th, right? So this also here is the 1.369. 1.04 to the 8th. All right, so if you wanted to rewrite that, you might see it this way. 1.04 to the 8n. So it's not divided by, it'd be 8 times n. Those are all giving you the exact same function. N is the number of 8-year periods.
So it's saying like the initial would have changed, but that percent changes what years.
Yeah, so every 8 years, we have this percent change of 36.9%. It's still going to give the same salaries, but it's just a different index on the input. So if n was 2, how many years is that? That's 16 years. If n was 2, because it's 2 8-year periods. All right, so it makes sense because if you plug 2 in for n, you'd be multiplying by 1.04 16 times, so 16 years, right? Make sense? Okay, so how could we use this 8-year growth factor, 1.369, to find the salary in year 15? So how could I use this growth factor, 1.369, to find the salary in year 15? Did anyone figure that out? What would you do? Yeah.
Do it to the second power and subtract 1.04. So you're 15 times 16.
Okay, something like that would work. It's kind of a maybe a longer way than I was thinking.
I did a fraction of the exponent being 15/8.
Okay.
It would be 1.369 to the power of 15/8 because you're going 15 years. It's not going to be times 2. Otherwise, it would be 16/8, which would be the power.
Okay, so you make it it's good, but it's still making it a little more complicated than I was looking for. Yeah.
Can't you just start with the value of year 7?
Yeah.
And then just plug that into the formula and use 1 as your n?
Yeah, so what does the 8-year growth factor do? It gives you the salary 8 years later. So if we knew the salaries 8 years before, we could just multiply it by the 8-year growth factor. That was what I was hoping you'd see. We could just take the salary in year 7 and multiply it by the 1.369. So yes, there are other ways to do it, but I think what I wanted you to see was to use the 8-year growth factor to get year 15, we're going to take the 7-year salary and multiply by 1.369, which advances us 8 years forward. And what do you get?
72,861.
Point?
19.
If you wanted that in a function, would you use the original 41,000 and then of 1.369 to the 7?
No, because that would be that would give you so 41,000 times 1.369 to the 7th, that'd be 7 8-year periods. That'd be 56 years. So if we wanted to get the salary for year 15, how could we use this function here, f of x? Yeah, x would be 15, because that just tells you the number of years, right? So it would be harder to use this function to get year 15 because we could get year 8 and 16 and 24. So it's not it wouldn't be convenient to get year 15 using this function. But we can easily do it by multiplying the 8-year growth factor times salary in year 7.
Would it work with g of n if you raised it to the 1/8 n?
You want to raise the function to the 1/8 n?
No. So you have 1.369.
Okay.
Raise that to the 1/8 n. And that gives you
That'd give you the 1 year salary.
That just takes you back to this function.
the.
Yeah, that just takes you back to this function right here. Okay. Other questions? So let's talk about one more thing on this, and then we'll move on to decay. So notice what was the, yeah, sure.
Why did you, like, if we wrote all the tests, the G of N, the 1.369?
Yeah.
And why did you simplify it to the 1.04? Same thing?
Yeah, they're all three of those, just three different ways of writing the same function. And you should be able to recognize all three and see how they work. So that truly is the 1.04 to the 8th. And then this is a rule of exponents. You could just multiply the 8 and the n together.
So if we wrote a test, would you see the first one or the third one?
It could be either. Yeah, it could be either. So yeah, so I'm pointing that out so that you know that you're responsible to understand them all. Your homework has some questions like this, so that's why I wanted to point that out. Okay, cool. So let's just look at what was the 1 year percent change? What's the 1 year percent change? Percent change. 4% increase. What was the 8 year percent change? 36.9%. So why isn't the one, so what is 8 times 4%? What's 8 times 4? 32. So why isn't the 8 year percent change just 32%? Why is it greater than 32% if we're just taking a 4% increase every year? What's not constant? The percent change is 4% every year. It stays constant, but you're onto something, yeah.
The previous outputs are increasing.
Yeah, because the outputs are increasing. What's 4% of this compared to 4% of this? Bigger, right? So the amount of increase in dollars is going up, even though the percent stays the same. So because the amount of increase goes up, the cumulative effect over many years is more than just 4% of the first amount. So if we took 4% of the first amount and just added that dollar amount every year, then we'd have a 32% increase. But you get a higher dollar amount every year. So 4% of a higher dollar amount is a higher dollar amount. So the cumulative effect will be higher than 8 times 4%. We'll talk more about that next week. Okay, let's look at so here's a situation with decay. So I'm going to give you a list of questions again. So this Bob begins with an initial salary of $38,000, and his salary decreases every year by 2%. Okay. So some people are just thankful they have a job, right? This is not a great situation, but sometimes times are tough. So what's the 1 year decay factor and percent change? Okay. So, and then number 2, write the function. For a salary after X years. All right, find the 5-year percent change of salary. Or 5-year growth factor, decay factor. Okay, find someone to talk to. Show them what you're doing. Compare answers. Compare your thinking. Compare what you're thinking. Everybody, go. I want to move pretty quickly so we can have time to get to the worksheet you did for today. It's in order. Find someone to talk to. Compare your thinking. Go. Okay, how do we find the 5? So agree with the first two? K factor is 0.98. Percent change is decreasing 2%. Okay, what is the, and then this is the function. So what's the 5-year decay factor? The 5-year decay factor is going to be what we multiply to get 5 years later. 0.98 to the 5th. And what do you get for that? 0.904. So write that as 1 minus, so what number do you subtract from 1 to get 0.904? 0.096. So if you can't do that in your head, that's fine. Just put an x there and solve for x, right? So put an x there and solve for x. So what number do you have to subtract from 1 to get the decay factor? So what's the percent change? 9.6% decrease. So the salary after n 5-year periods would be g of n equals starting value 38,000 times 0.98 to the 5th. That's the 5-year decay factor. So therefore, n would be 5-year periods. Whatever your increment of the exponent is has to match the factor. So that's how you can remember how to do it. Okay? So how could we find the salary after 13 years? What could we use on here to find the salary after 13 years? F of x, what would you do? F of 13. And f of 13 is? So what do you get? Anyone get that salary? Quick, so we can get out of here. Did anyone find that? Thank you. Now, what would I need to directly from this salary get the 20-year salary, the salary at 20 years? What would I need? So to get from 13 years to 20 years. 7-year growth factor. What's the 7-year growth factor? No, what's the 7-year growth factor? Take the 0.98 to the 7th. If you multiply that by 0.98 to the 7th, so we're advancing forward 7 years. So this times the 7-year decay factor would give us the salary 7 years later, or the salary at 20 years. Okay, if you've got questions, I'll leave this up if you want to catch me with a question on the way out.